Hello guys, in this video we'll be looking at the determinant of a matrix, and the determinant is a very special number that can be derived from a square by square matrix, and we know that we achieve a square by square matrix when there are even amount of rows and columns. So we could have a 2 by 2 where we have 2 rows, 2 columns. That's a square matrix. And the elements in the square matrix, you would achieve a square number. So a 2 by 2 matrix, we know that 2 times 2, 4, will have 4 elements in that matrix. And a 3 by 3 matrix, 3 is 9. So we'll have 9 elements in a 3 by 3 matrix. So in this video, we'll be focusing on finding the determinant of a 2 by 2 matrix. All right. So how do we go about finding the determinant of a 2 by 2 matrix? Let's get straight to it. All right, so what do we use to represent, or instead of writing that long-term determinant, we normally use 2 bars, and in between the bars we put the name of the matrix. So in A, it's A. So the determinant of A, we just write it like this. 2 vertical bars and the letter in between. So to find the determinant of A, it's the leading diagonal. So the matrix starts right here, right? And when we think diagonally, we think slant, like a slant line, a slope. Yeah. So it's the leading diagonal, the product of the leading diagonal, minus the product of the non-leading diagonal. So it's 2 times 8, the product of the leading diagonal, minus the product of the non-leading diagonal, 4 times 6. So the determinant of A is equal to 16 minus 24, which would give us a negative 8. So the determinant of matrix A is negative 8. Let us try for B. Remember, it's the leading diagonal. So we can achieve the leading diagonal. It's just that slant line that starts with the first element in the matrix. So it's negative 2 times 3. So the determinant of B is equal to negative 2 times 3 minus the non-leading diagonal, which is 4 times 0. I use an arrow to represent the non-leading. So it's negative 6 minus 0, and we know that that would give us a negative 6. Sorry. So the determinant of B is equal to negative 6. Now we are going to find the determinant of C. So it's the leading diagonal, which is 2, 4. So the determinant of C, you remember 2 vertical bars, and in between we put the letter of the matrix, or the name of the matrix. So it's 2 times 4, which is 8, minus the non-leading diagonal, which is 8 times 1. So simplifying, we get 2 4 is 8 minus 8, and that would give us a 0. A point to note, once we have a matrix that has a determinant of 0, which means we can't find an inverse for that matrix. It is called what we refer to as a singular matrix. So we derive a singular matrix when the determinant of that matrix is 0. And as mentioned, the determinant is a special number that we get from a square matrix, and it's helpful for us when we want to when we are doing the inverse of a matrix. All right, but once we do the determinant, we do the steps, which is the leading diagonal, the product of the leading diagonal minus the product of the non-leading diagonal, and we get 0. We have what is called a singular matrix, and we can therefore, at that moment, we know that there's no inverse for that particular matrix once the determinant is 0. Again, thanks for watching. I do hope you learned something today. And don't forget to like this. If you like this video, give it a thumbs up. You can share with a friend and tell that friend to continue the trend. Sharing is caring, and God loves a cheerful giver. So if we can give by sharing, that's a good thing. And don't forget to subscribe to our channel so that you know when videos are added, so you can watch and learn each and every day. Thanks again. See you in the next video. Bye. Love you all.